and it won't be. Right? So something like this. So the median class. Now I won't explain all these. I'm going to write this once because if you can't. My feeling is if you can't
understand that,
you won't. The formula won't be able to write it. But if you were to write it down. So LM, now that used to be the lower or the left of the modal, now it means the lower or the left of the median. So if you look at the picture, actually in this case the LM for the mode coincides with the LM for the median. I'll explain that in a second. So if you're calculating the mode here, this is the LM because it's the biggest one. But if maybe this was a bit bigger, this might have been the thing where you got up to halfway. Do you know what I mean? So it's a coincidence that we added up to 47 and we were still short of the 50 and that we came into the 50 here. It could have happened earlier. So for the mode, this is definitely the LM, but maybe not for the median. As I said, if this was 18, you'd add 33, and this would be where the median is. That would be the LM. That's that. Plus, so you're now going to take a proportion of the data. So if you look at the tree, that corresponds to, not the point tree, the tree. So that was the difference between all the data up to 2.35 less half the data. So if we went the whole way up to 2.35, you'd have 76 of them. We didn't want all that. So this would be called probably something like big F, standing for cumulative frequency. That's for the, so that's on the next one. So that would be like your 76. No, that's not quite right. So it would be the n over 2, the 50, take away actually the lower one, which was 47. 50 take away 47, the 3, divided by the frequency of the median class, that's the 29, times the C. So that would be the formula, but you'd have to look at the thing above, then make yourself understand these symbols, and then you have a formula, but I wouldn't go further than that. I actually think it's easier without the formula. I taught this with a formula, and eventually I thought, because what does that mean? What does that mean? What does that mean? It's easier just to kind of understand it, and if you can't, learn how to do the ogive. Okay. Next question there was using the assumed mean method to determine the mean and the standard deviation. Now there's no suggestion here that this is a sample or this is a population, so when in doubt you can just use the population formulas. If there's a suggestion that it's a sample, I want you to use the sample ones. But if you don't, I'm probably not going to dock marks, although I do want you to do it. There's no suggestion this is a sample. No, there's no story behind the data. I think the one you have, it probably will suggest it's a sample. It might even say a sample, so you should use the sample. But as I said, I'll just probably be generous and give you the formula, or give you the marks if you use the wrong formula. So because there's no mention of sample, we're going to use the population formulas, which are these. So these ones here, these are the population statistics. So like you see the one below, it says a sample. So use the slightly different ones. So we'll probably make that remark on the next one where instead of mu and sigma, it'll be x bar and s. So we come up with an assumed mean. Now, it doesn't actually matter what we guess, but just looking at the histogram even, if you were to guess where the average would be, where would you say?
Maybe like 24, is it not?
In that one? You can run with that one. So you take the midpoint of that. So you take, I think that would be 1.9. You can run with that. I'm running with 2.2. No particular, it doesn't matter. Either of those will be okay. If you go over here or over here, the numbers are going to get bigger. So I'm going to say the mean is probably somewhere in here and here. It probably makes sense to go maybe where the mode or the mean is, or not go too far away from that. You can do whatever you want. I'm going to go with 2.2. So you kind of, it's like throwing a dart. It's going to be around 2.2 and you're going to adjust that. So we start with this. It's perfectly okay to use maybe 1.9. I don't think it makes as much sense to go to 2.5. It has to be a midpoint though. Now here the table is done sideways, right? Now you might say, oh, why did you do the tables a different way? I didn't actually do it on purpose, but actually I'm quite happy. The important thing is you go from the formula and you get all the stuff you need. So if you look, you need the F's. Well, the X's and the F's you kind of have. Now remember, these X's are midpoints of the classes. The F's are with them. Now you need D's, so the D's come a little later. You need F by D, so I have F by D. I need F by D squared, so I put D squared, and I need FD squared, so I put FD squared there. So the table comes from the formulas. Now I've written them whatever, horizontal or vertical now, it doesn't actually matter which way you do it. So this is where I'm saying the assumed mean is. The F's are there. Now the D's, so the ones that are bigger, this is +1, 1 bin away, 2 bins away, 3 bins away. This one is -1 back, -2 back, -3 back. Now I just calculate what else I need. I need F by D, 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 F by D. I also need D squared, so I square them. Now be careful, if you put -3 squared into the calculator, you're going to have an issue, because -3 squared is not the same as -3 squared. The calculator here will give you -9. You all know minus by minus is plus, it should be 9. So make sure you make that positive. So squared, 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 squared. And then we finally need F by D squared, F by D squared, 8 by 9, 15 by 4, 24 by 1, 19 by 1, 4 by 4, 1 by 9, 9.
Were you just using the sigma formula?
We're using both of them. It asks for the mean and the standard deviation.
Oh.
So the top one is the mean and the bottom one is the standard deviation.
You have to put out make that table up in the exam. Because it's just the numbers on the right one.
Say again?
Joe, will we have to make that table out in the exam?
Yeah, I think it's kind of tricky to do without it. Are you suggesting?
Because is it only the numbers on the far right working interesting?
Yeah, yeah. I mean, if you give me the answer, you see, what I would say is if you just write down 2 right answers, I'm probably going to give you all the marks. But if you just write down 2 wrong answers, you're going to get nothing. So you'll probably be advised. So like I think this is a daft way to do these things. Actually, what the lecturer did kind of convince me that if you're doing them by hand, this is actually an easier way of doing it. There are other ways of doing it. The tables are harder. Formulas are a bit more complicated. So I'd nearly advise you to do the table. If you give me the right answers,
Just see if you think it's something, it's just the numbers on the right.
yeah, but I suppose there's a lot in those numbers, like in particular the D to capture. Very easy to make a mistake, I would say. Like if you wanted, you could kind of go back. If you did want to run it that way, you would go back and you would say you'd put the A here. And so your D's, this would be +1 in the D, +2, +3, 0 in the D, -1, -2, -3, and I'd give you a chance of doing it there maybe, right? But it's risky, I think, if you just give me 2 wrong answers, you get nothing, and there's too many marks going really to say that. But if you do it and you get it right, I'll give you the mark. Okay, so we need to add up F by D. Now that's not add up F by add up D. It's add up F by D, which is this. Add up F was 100, we should know that from earlier. Add up F by D squared, add all those up. And then everything else I think we have. What's C? well, 0.3. C is the width. So C is EG equal to, so if you look at the very first one, 1.45 minus 1.15 equal to 0.3. So once you've tabled on the formulas are straightforward. So mu equal to 2.2 plus 0.3. Add up F by D, that's minus 48, over add up F, which is 100, and we'll go to the calculator at that. I'm getting 2.056, that's an equals. And then this population standard deviation sigma is equal to C, which is 0.3, square root. Add up F by D squared, 200, over 100, minus add up F by D, which is minus 48, over add up 100, add up F, which is 100, squared, and surely this will be approximate. Uh, 3991. You could from there be asked to calculate the coefficient of variation. So it would be this guy divided by this by 100%. To do the skewness, you'd have to go off and calculate the mode. Sure, we'll just write down the mode there, it's handy enough. So the mode, that's probably easier with the histogram there, so maybe I'll bring it back a little. Everyone okay there? I'll have it down the bottom if you need it. So the mode is, well, write down the formula, Lm plus C times L over L plus U. That's the formula. Yeah.
Sorry, what are those symbols on the right side?
Okay, so I'll show you on the thing, and then I'll show you the thing. So the L, a few pages back. So the LM, we're going to explain. Well, it's actually it's on top page 83. Small L, yeah. So it's just the difference in heights here, and U's difference in heights there. So LM is so you're going to think it's in here, okay, and you're going to start with this and add on a little bit. So the LM is the 2.05. The width is the same. Now the L is the difference in height, so you're putting it in here. It's in the biggest one. So the L is the difference between these two, which is what? 5.
It's always the biggest one, so is it for L?
For the
Small L.
no, the mode is where this is biggest. So you're going to start at the midpoint to these, the left point, which is 2.05. And then you're going to add on a bit. The C is the 0.3. So the L is the difference between these. So the lower difference, which is the difference between those. And then the U is the upper difference, which is 10.
Is that 5 over 5 plus 10 multiplied by 0.3 or
Yes.
0.3 on the top then? No.
Same thing.
0.3 is separate though?
Same
what is it?
thing.
Yeah,
Same
sorry.
thing. So the peak we're putting around 2.15, which is if you look at it, because there's slightly more data to the left than the right, it shouldn't be at the midpoint, it should be slightly pushed to the left. So I have another question now, which has actually pretty much everything in it except the median. So this was the question for the median, and now we're going to do the question for the, yeah, was there a question?
Where's the median in that then?
Previous page, was it? Did we do it?
Oh, yeah.
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 So again, sorry about the small numbers. I know if your number, whatever it is something like 0 to 1, 1 to 2. It's just nicer numbers than these, because this was 0.5 to 0.54, 0.55 to 0. So that's how to fix it. So sample. Now I would like you, as I said, to use the sample statistics.
So you know if you pick 1.9, you know it's A.
All the D's will be different?
D's will be 1.1234.
Yes.
Minus 2.
Yeah, and you get the same answer in the end. So picking the A, just the cleverer you pick it, the smaller the numbers in the tail are, but you'll still get the right answer. So Stan, yeah?
Sorry, I just come back to
Okay.
you know, just on part A, we drew out the histogram.
Yeah.
You know the calculation we done there?
The
Just for
median,
the median?
that was part B. So there's two different ways of calculating the median. I guess.
Oh yeah. So if we done that first part, we wouldn't have to.
You wouldn't have to do the old guide, no. Now, other questions?
And what's the best practice for us? For the exam, like would we?
I would say whichever one makes more sense to you.
Is it?
I'm kind of giving you a hint there because the other questions would say do an OGIVE.
Oh, all right. Yeah.
So I don't think you'll have to do an OGIVE if you don't want
You
to.
still have to draw a histogram, don't you, just to
Yeah.
get the label and go.
Okay.
And we'd be given every formula then that's on that.
Every formula, not the one we drew in the bottom
No,
of the page.
okay.
Yeah. So this one says draw an OGIVE, for example. So if you now there's the interquartile range. Shite. Now you know you can't be asked that. We'll drive on with the example anyway, just for I think we might need interquartile range a little bit later on in a different question, so I may as well talk about it again. Okay. So this one says draw an OGIVE, so we will do it for this one. I'm going to add one more thing to this one, which is less than 0.495. How many of the data points are less than 0.495? 0. It's if you were to know. Now, of course, some of us are probably going to do an OGIVE, so there's no harm doing it again. It probably makes sense. It helps your graph to do this one. Okay. How much of the data is less than 0.545?
3,
Off you go.
11, 21, 41.
55, 59, 60. So you do that, and then you do f versus less than x. So that would be the upper and lower class boundary values, and you just don't worry about that. That was the way you ran that before. They'll just be 0, 10, 20, 30. So this is a bigger one. So I'm just going to take this away because it won't sit. But so you plot these. So you've got less than 0.495. We have 0. So you'll probably have a nicer scale to run on. I think your one might be 0 to 10, 10 to 20 to make the boxes in that way easier. Then less than 0.545 is 3, something like this. The next one is 11, something like this. Next one is 21, something like this. Next one is 41, something like this. Next one is 55. Your ones are probably more accurate now. And then 59 and 60. So So this yoke is supposed to capture the curvy nature of it. You could join the lines, but that wouldn't be a whole... Joining the lines, I think, would be the same as the formula we were using for the median. You want to put a bit of curve in it. Now the question asked for the interquartile range, we'll do that. We'll also just throw in the median as well. So the interquartile range is the middle 50%.
Say that. Unlikely to come up with it.
Second?
Unlikely to come up with it.
I just... you're better off just keeping it open for the time being. I think we might need this a little later on in the match, so if we just... Yeah. Look, it's my fault really if I shouldn't have said anything about the exam. It kind of hurts the overall, so don't think like that just for the time being. So the middle 50%, that's what the interquartile range is. So it's Q3, which we'll explain in a second, minus Q1, which is width of mid.